In this video, we will explore the AppDomain namespace. We will start by creating a console application and making a reference to the dodSON.Core assembly. Next, we will create a class library which will contain the type that will be loaded into the separate app domain. Then we will need to add a reference to the RemoteData assembly to the main demo application. In the remote class 1, we need to add the Serializable attribute and inherit from the MarshalByRefObject. This is vital so that we can access the type across application domain boundaries. Next, I will add some properties to access and a method to invoke. The method will take a value and also display the current app domain it is running in. I will also override the ToString method, which will make displaying the type's property values easier. Here is the reason I referenced the dodSON.Core assembly, to make it simple to display the byte array. Now to the main application. The first thing we will need to create is a remote app domain factory, which will allow us to create and control types in a separate app domain. The remote app domain factory requires a type proxy settings, which describes the type to instantiate and the environment to instantiate it in. The type proxy settings requires the assembly qualified name of the type to instantiate, the file name containing the type, the file names of any assemblies to be loaded before instantiating the type, the directory where the file containing the type resides, and the private bin path, a semicolon-separated list of directories where the .NET system will probe for other required assemblies to load. That completes the type proxy settings, which will be injected into the type proxy factory. Next, we will output the console application's current app domain ID and whether the instance is loaded. Then we will load the instance and again display whether the instance is loaded. Now that the instance is loaded, we will display the default values of the instance. Then we will change the instance values and display the changed values. After that, we will invoke the hello method on the remote instance displaying the results. Finally, we will wait for the user to press any key, allowing the user to see the results before the console application terminates. Compiling and running the demo application shows that the console application is running in app domain 1 and the instance is not loaded. Next, the instance is loaded and the default values are displayed. We change the values and display the new values and invoke the hello method, indicating that the hello method is running in app domain 2. This demonstration illustrates how easy it is to create application domains with automatic lifetime service sponsorships by creating a type proxy factory, injecting it with type proxy settings, and then using that factory to gain access to an instance of your remote type. However, if your goal is to simply invoke a method on a type or execute some code in a remote application domain, then the AppDomain class can make that even easier. It provides a static execute method which will invoke a function in a separate application domain. It takes a private bin path, which is a semicolon-separated list of directories that the .NET system will probe for required assemblies, and a state object to pass into the remote function. The function will create an instance of the remote class and then simply return the results of invoking the hello function with the state object that was passed in. Finally, we simply invoke the AppDomainHelper execute method and display the results. Compiling and running the demo application shows that the console application is running in app domain 1, and the results of the AppDomain execute method indicate that the hello method is running in app domain 2. The AppDomainHelper execute method makes it even simpler to execute code in a remote application domain. This video demonstrated some of the basic functionality of the AppDomain namespace. See the dodSON software library help file for more information.